Welcome to physics class. Good morning, everyone. My name is Muhammad Giyasuddin. My dear students, today we are going to discuss about another important topic, numerical based on particle trapped in one-dimensional box. Numerical based on particle trapped in one-dimensional box. So our first numerical is compute the lowest energy of a neutron particle confined to a nucleus which is considered as a box with size is 10 to the power minus 14 meter. So this is our first numerical problem. The statement of this problem: compute the lowest energy of a neutron particle confined to a nucleus which is considered as a box with size is 10 to the power minus 14 meter. Okay. So the given information of this question, solution: given particle is neutron, this is clear that particle is neutron. So mass of neutron is m equal 1.67 into 10 to the power minus 27 kg. Also Planck constant H equals 6.62 into 10 to the power minus 34 joule second. Okay. And this is width of potential wall. Okay. So this is L equal 10 to the power minus 14 meter. And compute the lowest energy. It means that ground state energy. So for ground state energy, N equal 1. Okay. We are going to find out E1 equal what? Okay. So we know that E equal n square by n square h square divided by 8 m l square. Okay. This is our formula. And in this formula, m, this is the mass of particle, l, this is the width of the potential wall, between potential wall, and h is Planck constant, and n is orbit number, that means energy level. Okay. So E1 equal the value of n equal 1 square. So 1 square into H Planck constant H equals 6.62 into 10 to the power minus 34 whole square divided by 8 into m, mass of the Newton particle equal 1.67 into 10 to the power minus 27 into L, the value of L equal 10 to the power minus 14 whole square. Okay. After solving this part, we get the result is 3.286 into 10 to the power minus 13 joule. So this is our required energy. This is our required energy. For your better understanding, I am going to repeat this once again. The statement of this question: compute the lowest energy of a neutron particle confined to a nucleus which is considered as a box with size of 10 to the power minus 14 meter. Okay. So the given information, lowest energy, that means ground state energy. For ground state energy, n equal 1. Okay. And particle is Newton. So mass of particle is 1.67 into 10 to the minus 27 kg. And H is Planck constant 6.62 into 10 to the minus 34 joule second. And L is width of potential wall. So L equal 10 to the power minus 14 meter. We know that E equal N square by H square divided by 8 ml square. For ground state, we can write E1 equal N1 square H square. Okay. So the value of N equal 1 square into H square, that means Planck constant, the value of Planck constant square. Okay. Divided by 8 into 1.67 into 10 to the minus 27. And the value of L equal 10 to the power minus 14. Okay. After solving this part, we get 3.286 into 10 to the minus 13 joule. Okay, our next numerical problem is this. The statement of this problem: the lowest energy of an electron trapped in a potential well is 38 electron volt. Calculate the width of the well. Okay, so the given information of this question, solution: particle is electron. This is clear that, so mass of electron equal 9.1 into 10 to the power minus 31 kg. And also Planck constant, this is equal to 6.62 into 10 to the power minus 34 joule second. And lowest energy, this is ground state energy. So N equal 1. Okay. And energy is 38 electron volt corresponding to ground state. Okay. So we can write E1 equal 38 electron volt. Okay. And as we know that electron volt is not SI unit of the energy, so it should be converted in SI system. So we can write 38 into 1.6 into 10 to the power minus 19 joule, because we know that since 1 EB equal 1.6 into 10 to the power minus 19 joule. So we can write 38 electron volt equal 38 into 1.6 into 10 to the minus 19 joule. Now we need to find out, calculate the width of the wall. Okay. So L equal what? We know that En equal N square H square divided by 8 ml square. Okay. So E1 equal N square H square divided by 8 ml square. Then we can write L square equal N square divided by N square H square divided by 8 m E1. Okay. So L equal under root of N square H square divided by 8 m E1. Now L equal under root of the value of N, this is equal to 1. So 1 square into H square, that means 6.62 into 10 to the power minus 34 whole square, and divided by 8 into mass of electron 9.1 into 10 to the power minus 31 into the value of E1, this is equal to 38 into 1.6 into 10 to the power minus 19. Okay. After solving this part, we get L equal, this is equal to 9.959 This is equal to 9.959. 9.959 into 10 to the power 11. Sorry, 10 to the power minus 11 meter. So this is our required answer. That means width of the potential wall. For your better understanding, I am going to repeat this once again. The statement of this problem: the lowest energy of an electron trapped in a potential well is 38 electron volt. Okay, calculate the width of the wall. So the given information: particle is electron, so mass of particle is 9.1 into 10 to the minus 31 kg. Planck constant 6.62 into 10 to the minus 34 joule second. Since lowest energy, so we can write n equal 1 and E1 equal 38 electron volt. Electron volt is not SI unit of the energy, so it should convert it in SI system. So 1 electron volt equal 1.6 into 10 to the minus 19 joule. So we can write 38 into 1.6 into 10 to the minus 19 joule. Okay, L equal what? We need to find out L equal what? We the value of L. We know that En equal n square h square divided by 8 ml square. Okay, so E1 equal h n square h square divided by 8 ml square, and L square equal n square h square divided by 8 m E1. And L equal under root of n square h square 8 m E1. When all the values substituted in this under the root, then we get 9.959 into 10 to the minus 11 meter. Okay, our next numerical problem is the statement of this problem: find the energy of an electron in ground state moving one-dimensional box of weight 1 angstrom. Given mass of electron is 9.11 into 10 to the minus 31 kg and Planck constant H equals 6.62 into 10 to the minus 34 joule second. Okay, so the given information of this question, we can write solution. Given particle is electron, so mass is also given 9.11 into 10 to the power minus 31 kg. Okay, and Planck constant is also given, so this is equal to 6.62 into 10 to the power minus 34 joule second. Okay, and width is 1 angstrom, so L equal 1 angstrom. Okay, and angstrom is 1 angstrom equal 10 to the power minus 10 meter. Find the energy of an electron in ground state. So U1 equal what? U1 equal what? And N equal for ground state N equal 1. Okay, we know that E N equal n square by h square divided by 8 m L square. This is our main formula. Okay, so E1 equal the value of n equal 1, so 1 square into value of h square, h 6.62 into 10 to the power minus 34 whole square, and the value 8 into value of mass value of electron is also 9.11, so 9.11 into 10 to the power minus 31 into the value of L equal width equal 10 to the power minus 10, so 10 to the power minus 10 whole square. After solving this part, we get the result is 0.37 into 10 to the power 0.6037 into 10 to the power minus 11 joule, and this is equal to, this value we can convert it in electron volt, so we can write 0.6037 into 10 to the power minus 11 divided by 1 electron volt. This is equal to 1.6 into 10 to the minus 19. After solving this part, we get 0.37 into 10 to the power 8 electron volt. So this is our required energy. Okay. Problem is the statement of this problem: find the energy of an electron. Find the energy of an electron moving in one dimensions is an infinitely highly potential box of width 1 angstrom. Okay. And given mass of electron 9.1 into 10 to the minus 31 kg and Planck constant H equals 6.62 into 10 to the minus 34 joule second. Okay. So the given information of this question, solution. This is our last numerical problem. Mass of electron equal given 9.1 into 10 to the power minus 31 kg. Okay. And Planck constant H equals 6.62 into 10 to the power minus 34 joule second. And Woods, this is equal to 1 angstrom. So 1 angstrom and 1 angstrom equal 10 to the power minus 10 meter. Okay. And n equal 1. N equal 1. So we know that E1 equal what? We know that En equal n square h square divided by 8ml square. So E1 equal the value of n equal 1. So 1 square into value of h 6.62 into 10 to the power minus 34 whole square, and 8 into the value of mass value of the electron equal 9.1 into 10 to the power minus 31, and L, this is equal to 10 to the power minus 10 meter whole square. After solving this part we get 6.03 into 10 to the power minus 18 joule. Okay, this value we can convert it in electron volt. So we can write E1 equal 6.03 into 10 to the power minus 18 divided by 1.6 into 10 to the power minus 19 electron volt. Okay, because we know that 1 electron volt equal 1.6 into 10 to the minus 19 joule. So after solving this part we can write 37.69 electron volt. Okay, so this is our required energy corresponding to ground state. Okay, thank you.